Hello everyone, my name is Mohamed Fouki, PhD student at Max at the University, also member of Information Technology and Modeling System Research Unit. In this session, I will present you our contribution, a new parameter optimization strategy to improve student performance prediction. During this presentation, I will proceed the following plan. First of all, I will define our problematic, then deep learning, the new way to train neural network, data used in this study, result, conclusion, and some references. Basically, classification systems are being used a lot in the learning systems, but several researchers in this field found themselves faced with the following problem. The systems are monolithic, hard to control, limited to a growing amount of knowledge, and the widely used data sample to train classifier models consists of correlated information caused by overlapping input instances. So, in this work, we present an optimized prediction model based on deep learning. So, what is exactly deep learning, and why is generally better than other data mining technique? The short answer is deep learning means using a neural network with several layers of nodes between input and output. This series of layers between input and output do feature identification and pre-processing in a series of stages just our brain seems to. Okay, you can say that multi-neural networks have been around for 30 years, so what's actually new? This is true. We have always had good algorithms for learning the width in network with one hidden layers, but these algorithms are not good enough for learning the width for network with more hidden layers. So what's actually new is algorithm for training many-layer network. Let's see, for example, this neural network. We have three variables and two classes, either 0 or 1. The first step is to initialize the width for each connection between the neurons, then starting by selecting the three first instances, which are 1.4, 2.7, and 1.9. So after defining the width for each connection between each layer, the algorithm generates the output, which is 0.8. Obviously, this is wrong if we compare it to the target output, which is 0. The next step is modify the width and repeat the calculation until we find the same value as the class, and so on. So repeat this thousands, maybe millions of times, each time taking a random training instance and making slight width adjustment. Generally, with learning algorithm for neural network work by making thousands and thousands of tiny adjustments, each making the network do better and the most recent pattern, but perhaps a little worse on many others. But eventually, by the unluck, this turned to be good enough to learn effective classifiers for many real applications. So the new way to train neural network layer is to start by the first layer, next one, the next, until we reach the last layer, which is our predictive class. Also, each of the non-output layer is trained to be an autoencoder with an absolutely standard width adjustment algorithm to reproduce the input. And by making this happen with a fewer units than the input, this forces the hidden layer unit to become good feature detectors. So, in order to have meaningful results, it was imperative to test our hypothesis on a real-world problem. So the prediction model has been developed based on certain input variables selected from database of an e-learning platform operated by Al-Maksad University for a distance learning public. The final grades of students in dataset are classified into excellent, acceptable, very good, good, and file classes on the basis of their section, test marks, selection marks, number of connections to the platform, interview score, and measure of their participation in the program. Using this optimized model, we could enhance the network accuracy to 91.91%. So like this figure describe only one instances has been classified incorrectly. Finally, this training strategy could decrease the correlated information caused by overlapping input instance, which will reduce the network training time and improve the performance of deep neural network system, particularly in solving complex problems involving a large number of input data. This is some of our reference, and thank you for your attention.